levels.
You must lose weight doing that.
Start by thanking Mike Covarrubias and Lynn Tollin, who've done a fantastic job, I think, putting this meeting together. Also want to thank all of you for spending some time to listen to me today. Now, what I'm going to talk about in the next few minutes is a topic which was alluded to by a questioner earlier on. What about the aging problem in society? What I'm going to do is talk about three things. One of some of the science that's going on right now that makes it quite probable that we're going to have anti-aging therapies being available in the near future. But then I'm going to talk about, well, what are the problems about getting this science to market? And then finally make a suggestion about, I think the Bay Area is beautifully placed to take a leadership role in this very important global problem of aging. Now, as we mentioned earlier, the problem actually comes out of a good thing. In the last 50 years, right, the life expectancy worldwide has gone up by about 2 or 3 years every decade, right? So on average, everyone on the planet is living about 5 or 6 years longer than their parents. Quite an amazing achievement. Now, there's of course always a downside to this, and the downside was alluded to earlier, right? Especially in countries which have a very low birth rate, you have things like Korea here, and over on this side, they're worried about 2060, 40% of the population are going to be over 65. In Japan, they're worried about in 2025 that there's going to be only 2 people supporting every pensioner. So these are big global problems, but this is not my area of expertise. I want to stay more and talk about the impact of aging on health. Now, this slide here is really quite amazing, right? When we stay pretty healthy up to the age of 50, and then after 50, all hell breaks loose, right? Every year, our probability of getting one of the major diseases goes up dramatically here, right? Now, what's surprising, the fact to me, is when we look in our medical system, I work at UCSF, 95% of the things we treat are age-related diseases, right? These are things like dementias, cancer, diabetes, listed them here, arthritis. So 95% of what we're seeing are diseases are aging related. So we could change this y-axis here. Instead of talking about the incidence of disease, we could look at the cost of healthcare, right? It's also going up dramatically. And so one of the reasons we're all suffering from the cost of healthcare going up locally, nationally, globally, is that there's more old people who are getting sick, and that's pushing up the cost. It's not the cost of drugs, it's not how much we're paying the doctors, it's just there's more old people, and therefore causing all the bad health. I have to get some water. So, now actually, for those of you who are data aficionados, you might look that this isn't actually a curve that goes up. Notice it plateaus, right? And then it dips down a little bit. Now that little dip might be something very encouraging. Because what it suggests, and the way this is normally interpreted, is that some people actually are somewhat resistant to getting old age diseases. And when all the people, those of us who are sensitive, die off, then those people live, and then the life expectancy gets higher again. So there's a subgroup of people that know how to stay younger longer. Now, that's probably not a surprise to you. Most of you probably know someone in their 70s, 80s who can still run marathons. You know people in their 90s whose brain is as sharp as a pin. I mentioned 2 of these here. One, a friend of mine, Jim Watson from Watson and Crick, he, when in his 20s, showed that the DNA helix was the explanation of genetics. But he's in his 90s now, and he's still incredibly articulate. You probably also read recently in the newspaper about David Goodell, right? He was working as a scientist in Australia up to the age of 102, still working, still functioning. So you don't have to get old in this regard. Now, what we are interested in is not longevity. I'm not trying to get people living longer. We're just trying to stay within the same lifespan, but stay younger longer. So why am I talking to you about this, right? So one of these, I have to see what I am. I'm a director of QB3. That's one of the 4 institutes of science and innovation in California. And we were created by the state government to try and take on major challenges in society. And so life sciences clearly aging as a major problem. So about 6 years ago, we were very fortunate just when we started getting involved with this. Larry Page also got very interested in this area. Now, he's interested in longevity, not staying younger longer. But the nice thing is we managed to get a partnership with Calico, the company that spun out of Google, and we're working together, QB3 and Calico. We also get money from the late Gary Rogers Foundation and from the Archer Foundation. So we've been working in this area of staying younger longer for some years now. What's really surprising, and what I want to talk about in the next few minutes, is it seems, and I'm only going to describe 3 potential therapies that might help us all stay younger longer. And I'm basically a professor, and I can't resist talking science, but I'll keep this as simple as possible. I hope you'll enjoy it. So what is the big insight here? Many people have different ideas of what causes aging, but the one that we find most compelling is it's related to the problem of inflammation. Now, what is inflammation? The way inflammation was been described since the Romans, since Galen, is that you've got these 4 characteristics. You see redness, pain, swelling, and heat. You know, you get a mosquito bite. You're very used to seeing those things. You rub chamomile lotion on it. What's causing inflammation? It's causing because cells are moving into the damaged area. Cells are moving in from your body into that area and are trying to fix it. So what inflammation really is your body trying to fix an insult. We still use the word inflammation, even when it doesn't have those 4 characteristics going back from the Romans. Inflammation is something we use medically to describe when you get the repair mechanism of the body trying to respond to an insult. Now, why is this important? Well, it turns out because it seems as though inflammation is really important in the aging process. Now, let me try and do this by an analogy here to the fire department. There's a fire. You've got a fire alarm, the fire is detected, it sends out a signal, the fire department comes there, they put out the flames. Then, of course, often they cause damage to your house, putting out the flames. It's usually a lot of water damage as well as a fire damage. But then it's okay, you repair the building. That's the whole process that we're used to in our society. Inflammation is the same thing in our bodies. When you get a damage, a mosquito bite, the cells send out a signal that brings in the repair mechanisms and they rebuild it. So that's what goes on. What happens in aging? Well, aging is often described as chronic inflammation. And what does that mean? It means 2 things in this context. It means the fire alarms don't turn off, right? They stay on. They should stay on, but so all the repair mechanisms keep thinking there's a fire and go looking for it. The other thing is that the whole mechanism, either the firemen are too ambitious and they're putting water on houses that aren't on fire, or the repair mechanisms, after you get damage, are not good enough. But what happens is an imbalance between the damage and the repair. So what do we get? We get loss of muscles, sarcopenia, loss of muscle mass. We get loss of thinning of skin. And of course, we get loss of brain cells. So this is what's going on in aging, a balance between damage and the capacity to repair it. Now, the nice thing about this gives you a clue right away about how you might think about slowing down the aging process. So if you could, for example, just get control of the inflammatory process, dial it back, make the firemen less enthusiastic, or improve the rebuilding capacity, then you might be able to slow down the aging process. And there are people developing compounds to do exactly that. The other thing that can happen is that the fire alarm, right, is still on, and it is on all the time, and it isn't being switched off. What's causing the fire alarm? Well, there's these cells in the body, which are for historical reasons called senescent cells, that send out the signals to tell the repair apparatus to come in. Now, those senescent cells, an individual cell can't make a very big signal, so what they do is recruit their neighboring cells to also become, to release the fire alarm signal. It's called spreading senescence here. So this means then, if you want to try and figure out how you can stop people showing aging, you could try and just kill the senescent cells, right? So the company, some of you may have heard about, Unity, in San Francisco. It just started a couple of years ago. I think it's already up at a couple of $100 million value. What they do, have a drug which they call senolytics, a drug which kills, lytics, the senescent cells. This is looking very, very promising as an anti-aging characteristic. Now, what makes all of this stuff about fire alarms and stuff seem plausible is that this remarkable experiment, which was done about 10 years ago, has been reproduced all over the world because none of us believed it initially. If you take an old mouse and connect it in its blood supply in this sort of chimeric mouse, it's called parabiosis experiments, so that the old blood is going into the young animal, what happens is the young animal gets old, right? Presumably those alarm signals are coming into the young animal. They're telling it their muscles get old, their brain gets old, their liver gets old, their skin gets old. So there are factors in the old mouse that's making the young mouse get old. So that fits with the fire alarm concept. But what's really surprising and blew us all away is the opposite is correct. There's factors coming out of the young mouse that's actually rejuvenating the old mouse, right? So their cognitive power is getting better, their capacity to repair muscle damage improves. So this means, in fact, there are factors. So this actually leads to the third possibility for a therapy, right? Can we find what the factors are in young blood and use them to try and keep people staying younger longer? So this science is really very, very exciting here for many of us. I hope for you too. And what you should be excited about is almost all of this is coming out of the San Francisco Bay Area. And we're working so well in this area because we have three big assets. One of them is there's almost all of the major institutions here, Berkeley, Stanford, UCSF, the Buck Institute, my own, QB3, we all have programs of different sorts working on can we actually stay younger longer. The nice thing, being the Bay Area, we actually all collaborate. We meet once every quarter, share our best practices, and try and figure out how can we actually move this ahead faster. The other great thing, and again is so characteristic of the Bay Area, there's a large number of very exciting companies coming out that are trying to take this science and develop into potential therapies. So Calico is run by Levinson, who used to be a postdoc at UCSF. Denali, a company that's also trying to control the firemen in a way. Their founder is Mark Tessier-Levine, the president of Stanford. Unity is a company which comes from Judy Campisi. She works at Lawrence Berkeley Labs and also the Buck Institute. She does the senolytics. And Alkahest, the one company that's trying to find out what's in young blood that makes people young again, they are actually, one of their founders is Tony Wiscori, who's a brilliant young scientist from Stanford. So academia is really feeding in to making a very exciting new industry in this type. And the last thing, which again is typical of the Bay Area, is that we have interesting ways of funding things. So many of you may have heard of Y Combinator. It's probably one of the best accelerators in the country right now, run by Sam Altman. He has just recently decided they're not only going to work in the IT space, they're going to work on aging. So they're putting $1 million into companies that are selected companies that will go into their accelerator. The other person here is Laura Deming, who at the age of 25 is now on her third longevity venture fund, and she's putting a lot of energy and money into this. Laura Deming actually was a researcher at UCSF when she was 12. Right? So she's one of these 20 under 20 people that Peter Thiel liked. So all of this is really quite amazing. Here we've got this great community, great stuff coming out. But if this were a Walt Disney movie, you'd about think this is about time the villain comes on the scene, right? There's got to be something wrong. So I'm going to think, what isn't working in the whole system, right? So the problem is, if you take away cancer, cancer is a very different area, and why it's different, I'll be happy to discuss later. If you take away cancer, there's almost no major drugs coming through the pipeline for any of the age-related diseases. Right? I just talked to the UCSF head of cardiovascular research recently, and he said there has not been a new drug in cardiovascular research, a cardiovascular treatment, for 30 years since the statins. If you look, as I am, looking in the Alzheimer's world, is there anything in the pipeline that's going to cure Alzheimer's? I can't see it in the next 5 or 10 years, right? So when you look at all these major diseases, diabetes, dementias, and so on, except cancer, then there's nothing coming through the pipeline. So that's intriguing to us in QB3 because we are unusual. We're not an institute to do science. Of course, we should get all these nice papers and prestigious journals and get awards, but we're an institute for innovation. We're supposed to be able to take that science and convert it into benefits for the people. And it's not working very well, working very poorly. Now, what might be the explanation? So let me tell a story about this one. I want to tell the story of Raylan Burke, who was one of the founders of the biotech era in San Francisco. She was in Chiron, then became division leader at SRI International. A vaccine expert, and she got involved with helping the company Elan develop a therapy that was hoped to work for Alzheimer's disease. The unfortunate thing for Raylan Burke, she developed early onset Alzheimer's at the age of 58. So she became an advocate for Alzheimer's Association, and she was an important advocate because she was actually getting the therapy that she helped develop when she was at Elan. Now, this is why I'm involved with this story. She's my wife, and I had to go with her when she was going through the clinical trials, right? And so here now is a $1 billion drug, and you're trying to ask whether this drug is working very well. So what do? You ask the patient to draw a clock face, right? And now you can see over 6 years of progression of Alzheimer's, you'd not be able to draw a clock face very well. But you're trying to measure whether your drug is working by asking how well a person can do a clock face, or you can show them the sign saying, give them a piece of paper saying, close your eyes and see if they do it. Or you can give them this little test down the bottom where you can recognize which one of these animals are there. And I'm sure most of you know this was actually the test given to our president when they were trying to test his cognitive abilities. And we all know that he passed, so it is good. He got it. Now, I'd like to try and emphasize this point about how important it is to be able to measure things, to measure the rate of progression of a disease. I think a good analogy is to think about the aircraft industry. Here are two airplanes, which are both over 60 years old, right? The B-52 and the 707. These planes are not with a walking stick and reading glasses. They're still fully functional, right? They're not getting old. They're still flying. What is it that allows us to keep airplanes flying that we don't have ourselves? The answer is, when you look inside the cockpit of those planes, they're measuring almost every parameter of plane function so that they can see when something is going wrong. They can catch it very early and fix it, right? Now, we don't have anything like this in medicine. We're like flying with a World War I cockpit of an airplane. We don't have those measuring devices. Now, this is really, you might think, really surprising. I told you earlier, there are factors in the blood that almost say whether you're young or you're old. You have rejuvenation factors, aging factors. Why can't we just look in the blood of humans to find out to get a quantitative measure of aging? Why can't we develop an aging meter, a little bit like the glucose meter? You know, diabetics can take a little bit of blood and can measure the glucose in their blood. Why don't we have such a thing for aging-related diseases? Now, it's not the problem of the science. There's lots of people measuring all sorts of things about patients as they get old, right? The government is supporting, and the United States government, the European governments are collecting data on old people. But we're not yet seeing someone coming up simply with a meter, right? An aging meter that you could use to ask if your therapy is working. So what is the problem here? Now, universities don't make meters, right? Governments don't make meters. It's only the private sector that's going to make these things. So why isn't the private sector coming up with measurements so that we can measure whether our drugs are working or not. And the answer, I'm sure it won't surprise you, it's money, right? The market economy, which of course we all love, we have to love, it's actually not working well in this situation. Why not, right? And I work in some venture firms, so this is based on actual experience. Somebody comes in with a great idea to start a diagnostic, which could be useful in this regard. And the venture capitalist will say, yeah, it's really great science, but I'm not going to make enough money out of this. It costs me almost the same money to get FDA approval of that diagnostic as it takes for me to get approval of a drug. But I can sell a drug for $100,000 to a patient. A diagnostic, I'm lucky if I get $100. It doesn't make any financial sense for me to invest investors' money, my limited partners' money, in this company. It's great science, I'm sorry, but we're not in this. We're in this to make money, as all venture capital firms are, right? So you might say, well, why aren't the big pharma companies doing it? Well, I've talked to them about them. Just 2 days ago, I talked to Merck about this. And one, pharma companies, that's not their expertise, making diagnostics. And also, if they were to make up a meter, put energy into making an aging meter, well, all the rivals could use it too, right? So they're not getting any competitive advantage. So the market system is just not working. Here's something we really need to solve a major science problem, and it's not working. So what can we come up with a solution that doesn't just want to, just have a villain? You've got to have someone that slays the villain. So what might be the solution? What I'd like to argue, and this maybe is really something that fits really well for the Bay Area, is we try and get a venture philanthropy fund which is focused exclusively on quantitative measures of aging. Now, how might this actually work in practice, right? As I said before, we have this incredible consortium of academics working very well together in the Bay Area and are making, as I described earlier, some really amazing potential therapies that can keep us all staying younger longer. The trouble is, those are virtual therapies. They're not actual. They're not pills you can get at the pharmacist, nor are they likely to be in the near future. What we need, as I said, is to have some way of developing these aging meters, metrics, so we can measure whether those drugs are working and so on. And I'm arguing that you need to have a special fund, and so we need to get limited partners who are willing to invest in that fund as a venture philanthropy fund. Now, those people, of course, venture philanthropists are still basically venture, and they'd like to see some money coming back to them. That's pure philanthropy if you don't get some money coming back. They like some money coming back. How can we increase the probability that those venture philanthropists will actually get some money back here? And this is where QB3 comes into this, my institution. What we've been doing for the last over 10 years now is actually working with venture funds. So we take all the great science coming out of the universities, and we get this blue ribbon investment advisory board, has people that you'd all know if you're in the field, who give pro bono advice and help us to filter out which companies look good and which ones really are not ready for prime time. We also have incubators, so we can put the companies in the incubator and see how they actually work. So we have mechanisms for essentially de-risking those startup companies and making it more likely that the venture philanthropists will see some money coming back. So this is when I talk about trying to put together a Bay Area global center on aging. I'm trying to think about bringing these various groups together. Now, I don't want to stop this showing block diagrams. I want to go back to what is really important about all of this, right? This is not like transportation or housing. This is something that affects all of you, all of the people you know, all your friends and your family. We're all going to get old. We're all going to be susceptible to these age-related diseases, and we have to do something about it. Now, right now, with the exception of cancer, there's nothing, it doesn't look good. It doesn't look as though there's anything coming through the big pharmaceutical system that's going to solve the problem of staying younger longer. It's our impression, our belief, that one of the ways to do it is to help getting biomarkers of disease progression, but we don't know, of course, if that's correct or not. So one of the things that we are doing in QB3 is to try and think, well, let's try and bring all of the community together, the people from academia, the industries, and the investors, into a conference which we're going to have on October 10th at Mission Bay, and to try and see, going over in more detail than we've done here, sort of the science behind what we've talked about, to see if we can, and also looking at the economics, to see if we can solve this problem. Because this is a major problem, but it's not a science problem. It's a problem that's only going to be solved if the scientists work with their community in the private sector to try and make this happen. So thank you very much for listening to me.